Dear students, today we will see the first technique of digital modulation, and that is amplitude shifting. So here I have shown the diagram of a binary amplitude shifting. Actually, in amplitude shifting, what will happen is the amplitude of the carrier will vary according to the instantaneous value of the modulating signal or modulating voltage or information voltage. Okay. Now in that it has to keep the frequency and phase of the carrier constant. It should not change frequency and phase. It can only change the amplitude of the carrier according to the instantaneous value of the modulating signal. Okay. So here what I have shown is the waveforms of a binary amplitude shifting. So I have taken data, a binary data as 1 0 1 1 0 0 1, and that data is represented in a line code electrically. You can see a pulse here, there is nothing here. For 1 1 again a pulse here, there is nothing for 0 0, and again 1 1 1 for 1. So whenever there is a binary 1, we are showing a pulse. Whenever there is no a binary 1, there is a 0, there is no pulse over there. So this is the representation of the binary data what we have taken 1 0 1 1 0 0 1. Okay. Now here there is a unmodulated carrier. It is an unmodulated carrier. That means its amplitude, frequency and phase are constant. Nothing is changed. So this is a carrier which is going to take this signal, this information, this data from one point to another in a long distance communication. Okay. Now once you superimpose these both, once these both get involved in the process of amplitude shift keying, then you can see output over here. Whenever the data is binary 1, you can see that carrier is present at the output. Whenever the data is binary 0, the carrier is absent at the output. Whenever the data is binary 1, carrier is present. Whenever data is binary 1, a carrier is present. Data is 0, carrier is absent. Data is 0, a carrier is absent. And data is 1, carrier is present. So whenever the data is binary 1, a carrier is shown at the output. Whenever the data is binary 0, there is no carrier at the output. So this type of output, whatever we get, is called as amplitude shifting. It is also called as on-off shifting. And it is a simple circuit what we can have for it, and it is the simplest form of digital modulation technique, which is called as amplitude shift keying. Students, now we will see a generation of a BASK signal. That is how a amplitude shifting signal is generated. Now in that case, we are going to use a main circuit called as product modulator. Now product modulator will be having two inputs. One will be the information signal, which is the binary data, which is represented in any line code type of signal. So here you can see the data is 1 0 1 1 0 0 1, and it is represented electrically in this way. Now this will be one of the input, and the other input will be a high frequency carrier signal, which is responsible for taking this data from one point to another. When these two signals are given as the input to the product modulator, so the output will be seen that whenever the data is 1, carrier is present at the output. Whenever data is 0, carrier is absent at the output. So the output you can see that it is for 1 there is a carrier present, and whenever it is 0, carrier absent. 1 there is a carrier present, 1 there is a carrier present, 0 it is absent, 0 it is absent, and again for 1 it is present. So this type of output what we get will be called as a binary amplitude shift keying signal. It is a form of your ASK signal.